I'm Seth Bergman, and this is an introduction to analysis of algorithms. What we're going to be doing is talking about what's called a big O analysis of running time for a particular algorithm. Let's take some fairly simple examples. Suppose I have a Java method. Its name is M1. It's a void method, and it has one parameter, an int. And all I'm going to have in this method is a simple for loop. I is 0, I less than n, I plus plus. And inside this loop, I'll have a simple print statement. Instead of typing out system.out.println, I'll simply say print I. That's what I mean. Simply print out the value of I inside that loop. And so the number of times that loop repeats will depend on the parameter n. If it's n is 100, the loop will repeat 100 times. So what we'll say then is that the running time for this method is going to be proportional to n. If I double the size of n and run it again, it should take about twice as long for this thing to run. Another way of saying that is that this method is big O of n. N is a measure of the running time of this program. And in general, n represents the size of the input. Let's take another example. I'm going to take this same method and instead of the parameter being n, it will be m. And it repeats, and m is the number of times the loop repeats. We still say that this algorithm is big O of n. And n is a more general term or variable which always represents the size of the input, regardless of what the input's name actually might be. Let's take another example. Let's go back to int n here, just for clarity. And now in this example, instead of having a print statement, I'm going to have another for loop. I less than n. J, this should be a different variable. J is 0. J less than n. J plus plus. And inside this inner loop, I'll print I plus j. And so the question now is, how many times does that print statement execute? Well, if the outer loop, if value of n is 3, for example, the outer loop will repeat 3 times, and for each iteration of that outer loop, the inner loop will repeat 3 times. So that would be a total of 9 times that the print statement is executed. What we have here is an example of a nested loop, a loop inside another loop. And so for a case like this, the running time will be proportional to n squared. I'll write n squared like this because I'm using a text editor that doesn't allow superscripts here. Big O of n squared. If I double the size of n, the running time will be 4 times larger. If I triple the size of n, then the running time will be 9 times larger. The running time will be proportional to n squared, and we call that big O of n squared. Let's take another example. Let's call that one M2, just to have different names here. Let's call this one M3. In this method, I'm going to print I in the outer loop, and then in the inner loop, in the other loop, rather, I'm going to print j. Okay, so I goes from 0 to n, print I. J goes from 0 to n, print j. Here again I have two loops, but they are not nested. The first loop will repeat, for example, if n is 3, will repeat 3 times. It'll print 0, 1, 2. And then the second loop will repeat 3 times, 0, 1, 2. So if n is 3, we'll have 6 times that print statements are executed. This is not a nested loop. So this is going to be big O of n plus n. N for the first, n iterations for the first loop, and n iterations for the second loop. Well, big O of n plus n is the same as big O of 2n. Well, we can simplify that because what big O of 2n means is that the running time is proportional to 2n. If it's proportional to 2n, it's also proportional to n. So we can take out that 2. It disappears from the big O notation. Let's take another example. This will be our method M4. And in this method, the loop will repeat exactly 10,000 times. We'll just have the one loop. Okay, here the input is n, the parameter is n, but the loop is always going to repeat 10,000 times, whether n is 0 or n is 2 million. And so the running time does not depend on n. We call this constant running time. And we'll write it as big O of 1. Big O of 1 means constant running time. The running time is not proportional to n. Let's take one more example. Well, I think we'll put that off and we'll do the other examples in another video clip. That's it for now.